So we're gonna go through your test, and I'm not gonna give you the answers specifically. I'm just gonna explain what they want in the questions.
Yeah.
Okay. So basically, they say two grade 10 learners investigate whether the mass is conserved during a reaction. They burn different masses of magnesium and oxygen to form a white powder, magnesium oxide. The following balanced chemical reaction represents the chemical reaction that took place. So if you look at your chemical reaction, it's 2 Mg plus O2, and it gives you 2 MgO. They say, is this reaction a synthetic or decomposition reaction? So this is a synthetic reaction because if you look at it, these are gonna add. These are added to each other to give you this. If it was a decomposition reaction, the reactant would actually be 2 Mg. Sorry. If it was a decomposition reaction, this would be your reactant, and these would be your product. But since it's synthetic, these are your reactants. These two are your reactants, and this is your product. So I don't know. Do you understand that part? Because that's how like you determine whether it's a decomposition or synthesis reaction. So in a decomposition, this is broken apart. But since the synthesis reaction, these combine to form this.
Adding. Yeah, I think I understand.
Yeah.
But now, why is it too much? Like, how would I give the answer?
To explain, you
so
say
what you just said now.
Yeah, basically, like when they say give a reason, like I already like I give you the reason before I actually give you the answer. So basically, I cover two questions all at once because I can't just say synthesis and not give you a reason why it's synthesis. So they say in this investigation, write down an investigation question for this investigation. They say they are going to investigate whether mass is conserved during the reaction. So the investigation question is mass conserved during a reaction? That's your question. That's the question that you're gonna answer. So now they're gonna ask you an independent variable of this investigation.
What did I say? Let me just check what I said. I mean, independent.
Independent variable, that just means the variable that does not, in this case, no, the variable that won't change. Nah?
Yeah.
They're burning it in oxygen.
Yeah.
Yeah, so I think the oxygen has to be an independent variable because they're burning because they burn different masses of magnesium in the oxygen. The oxygen is gonna stay the same, it won't be affected, but the masses of magnesium is the one that is being controlled. So basically, the independent variable, sorry, let me just try to scroll. 2 down here. Sorry. So what's gonna happen is that if you look at it, the masses of magnesium are controlled.
Mm.
The oxygen is constant. So the masses of magnesium is the independent variable because the, let me just, what is this thing now? Let me just do this. In this case, the masses of magnesium is going to be your X.
Mm.
And the amount of oxygen, because since it's going to be controlled, it's basically a gradient. And the MgO produced, that's going to be your Y.
Mm.
Oh yeah, sorry. The oxygen is constant, so it's not your gradient. It's basically C. So what happens here is that Y, the oxygen is controlled, the masses of magnesium is independent, and the amount of magnesium oxide produced is gonna be the dependent variable. So with that, like with just from answering the second question, I already answered the third one. So you see, so they say the chemical reaction indicating the states of each substance. So you know, oxygen O2 is going to be a gas.
Yeah.
They already told you it's a white powder, so that means it's going to be a solid.
Mm.
And
Wait, why is it a solid again?
sorry,
Why is it a solid? Like the
it's a powder.
so powerful is in as solid.
Powder is a solid
Mm.
because like it's not in water. It's not a liquid. Nor is it a
Okay.
gas. So it's solid. It just has a very high surface area.
Okay.
So I think the magnesium too has to be a solid. So this is basically the reaction that they want here is 6.2.4.
Mm.
And now I'm gonna go to the next question. So they're like, calculate the volume of oxygen that is consumed at STP if 5 grams of magnesium reacts with the excess oxygen. So now they tell you that 5 grams of the magnesium reacts with the oxygen. And they want you to calculate the volume of oxygen that is used. First thing you must do is to convert your 5 grams into the number of moles.
Mm.
So, like, remember, always convert any units that you have to number of moles when it comes to stoichiometry.
Okay.
So you're gonna have 5 and divided by the, oh yeah, you're gonna write your N is equal to M divided by the molar weight
Like
So
molar mass, yeah.
yeah, sometimes it's two capital letter M's.
We just write them.
Sometimes it's just M. Sometimes it's MW. So yeah, it just depends on however you're feeling that day, I guess.
Mm.
So now I'm gonna look at my periodic table. I think I have a periodic table on my PC. Um, so let me just go here. So periodic table.
So I help you. I can just use my one.
Nah, it's already gonna open up. So we're talking about magnesium. It's 24.3. So that's gonna be divided by 24.3. I don't know. Do you guys with your molar ways, do you write it to one decimal place, zero decimal place, or two decimal places?
That's one. Mostly just one.
Okay. So let me get my calculator. Now the number of moles is gonna be 5 divided by 4.3. That's gonna give
Zero
you
comma
0.21. Like
no.
in your case, they're a bit more lenient when it comes to the significant figures. So you can just say 0.21 instead of saying 0.215, however
Mm.
far it goes. So now, since you have this, you're gonna calculate. We're gonna use stoichiometric ratios to find the amount of oxygen that is used. So you know that this is gonna be your mg. This is gonna be your oxygen, the ratios. Then here you're gonna have 2 mg. Oh yeah, this is O2. And here you're gonna have 1. So now we know our number of moles of magnesium. That's gonna be 0.21 is to x.
Mm.
So you're gonna cross multiply this. You're gonna get 2x is equal to 0.21. Then that means you're gonna divide both sides by 2. Divide this side by 2.
Once is 0.10. Or you can say 1.
Let's just leave it like that. So it's gonna be the number of moles of oxygen. That's gonna be 0. That's gonna be 0.
105.
Yeah, 0.5 mole. Oh yeah, I forgot I forgot to state the units there. So it's gonna be mole here. So now they say they want you to calculate the volume of oxygen at STP. So now you remember that if you go to the back of your formula sheet, you'll have the number of moles is equal to the volume divided by the molar volume. Do you remember this? So now you have your number of moles, and you know that it's occurring at STP, meaning that your molar volume is 22.4, which is going to be liters per mole. And do that. So you make the volume the subject of the formula. You're going to have V is equal to N VM. So now your volume is going to be 0.105 into 22.4. So you just have to calculate that. You're gonna get your volume as
that is 2,352.
So this is your volume of oxygen that has been used. So if you look at it, always convert to moles, then use the stoichiometric ratios, then go to your final equation. And in this case, your final equation is the molar gas volume equation. But sometimes the final equation might be the concentration equation, you know. Yeah, so